this one as well. Okay, let's go to regression exercise D. So this is another example that you can actually see. If you have this kind of data, you need to convert them, you need to transpose them so that you can actually use a proper regression analysis. So what you can do is you control this one and then select here, and then you should paste and then transpose so that the data is arranged like this. The same for this one as well. You need to copy paste them. Copy, copy, and then paste it here. Alright, so in this case you can actually do two things, okay, which is you can do a regression analysis to find out what is the relationship between rainfall and the radims 1, and also relationship of the rainfall with radims 2. So let's try to do a regression analysis. So press data, data analysis, regression, okay. Your input wire range is usually the right hand side, so which means that you will be highlighting the radims. And then for the input X range is the rainfall. Okay, and then your output range, try to put it nicely here. Then make sure labels is clicked because there's label there, and then press OK. So this is your summary output. You can see here the significance F value. So the significant F value is 0.16432,615, which is more than 0.05. Therefore, there is no relationship between rainfall and the monthly catch fish by radims 1. So let's try to do the same again for radims 2. Data analysis, regression, this one, input Y range, in this case you select radims 2, and also X range, you choose rainfall. And then data, you put it here, and tables OK, press OK. Oh, there's an error. What happened? Oh, okay, it seems that there's some missing data at radims 2. So what you need to do is that try to copy paste this in table, and then radims 2, copy paste it again. Since this is empty, remember you need to delete them so that you can do regression analysis. Now let's try again to do the regression analysis. Regression analysis. Okay, this one, highlight this, and then this one, you highlight this part, then press OK. See, now you can produce your. So looking at the F value here, so significant F value is 0.02061222, which is definitely lower than 0.05. So therefore, it is safe to say that there is a relationship. Since F value is less than 0.05, there is a, since F value is less than 0.05, there is a relationship between rainfall and monthly catch by radims 2. Okay, so this is a negative number, which means that there's a negative gradient. It might mean that as the rainfall increase, the since this is negative gradient, which means that as the rainfall increase, the monthly catch by radims 2 decreases. Alright, understand? Okay, good. So next one, ANOVA. ANOVA is very useful if you want to find out if there's a difference between three sets of data. For example, in this case, the number of mammal species, island, mainland, peninsula. So you can actually use ANOVA to do this. So what you can do is you go to data, press data analysis, use the ANOVA single factor, press OK. Your input range, in this case, you only highlight the one with island, mainland, peninsula. If you highlight the number of mammal species, it will return as error. So just highlight this one until this one. Okay, make sure you click the label in first row so that the system know you have a label. And output range, you can put it here. Then press OK. Alright, so for ANOVA, the most important value that you need to look for is the p-value. Okay, p-value. If p-value is less than 0.05, there is a significant difference between the number of mammal species in the three different areas. If p-value is more than 0.05, there is no significant difference. Okay, so looking at your p-value, it's 0.006592616. That is definitely less than 0.05, which means this should be your conclusion. P-value is less than 0.05. There is a significant difference between the number of mammal species in the three different areas. Okay, that is the most important thing that you need to know for ANOVA. However, you are required to draw a graph, bar graph of the average number of mammal species in the three different islands. How can you do that? So what you can do is you make a new table. Okay, average number of mammals. Okay, and then island, mainland, peninsula. Okay, how do you find the average numbers? So in this case, you don't actually have to calculate manually. What you can do is, you see here, the average table given here, just copy paste that into the new table. So for island is 2.67, you copy it here. For mainland, 4.67, copy paste here. And for peninsula, copy paste here. Alright, so you need to make a bar chart. So you can do is you highlight your table, press insert, go to cluster table, and there you go. Remember, you need to put axis on the graph in order to get proper marks. So what you can do is go to your chart design, add chart element, axis title, primary horizontal, and also press axis title, primary vertical. So for your primary vertical, that will be average number of mammal species. Whereas for the axis title for the horizontal axis is areas or regions. Okay, so now you have a nice completely labeled diagram, and that should give you a good mark already, a good full mark for your graph. However, you need to learn how to actually add bar charts to each of these graph. So bar chart, not bar charts, error bars for each of these bar. So you need to learn how to add the error bars. Error bars is actually closely related to standard deviation. So what you can do is the standard deviation, you put it below the average number. To calculate the standard deviation, what you can do is you write STDEV, this one, and then you need to highlight the data for each of the three different area. So that is your 1.63 STDEV. Highlight this one from the original data, and this one STDEV, again that one. Okay, there's actually another shortcut to find the standard deviation. One way is to understand that standard deviation is equal to equals to square root of variance. So in this case, if you look here, standard deviation, you can actually use the Excel function, square root, and then click on the variance here. There you go, same number. Same thing for this one as well. Oh, sorry. SQRT, that one. SQRT, that one. See, you almost get the same. But if you guys are much more comfortable by calculating using STDV, that is fine as well. It's the same thing. Highlight that one. Okay. So this is like the one at the bottom is like a shortcut. You write SQRT and then just click on the variance there, island, and it will give you the same number. So you can actually to add error bars, what you need to do is go to chart design, add chart element, error bars, and then go to more error bars option. Since you have calculated your own standard deviation, what you can do is, if you have this here format error bars, go to custom and specify value. So your positive error value should be this one. Highlight the 3 value that you have calculated before. And negative value, same again. Highlight the 3 value. Then press OK. So now you have a beautiful graph showing the average number of mammals in the 3 different areas. Okay, good. Hope you can follow this. And lastly, for task B. So if you have encountered this kind of data, make sure you separate the data into 2 separate tables because you are dealing with texture and flavor, so don't combine them. You have to separate them. And then let's just delete this table. So you need to produce ANOVA data for flavor and texture as well as the bar chart and the error bars. So good luck in trying and thank you very much.